All right, we're going to try to do our best to do this like we would in class. So I want you to look at this graph on page 79 in your book and answer questions A, B, and C. And I know it's easy to cheat, but just pause, answer them, and spend a few minutes, and then come back to the video. So hit the pause button now, try to do this page. All right, I'm back. And so this is a scatter plot. So a scatter plot is when you're looking for a correlation or a relationship between two numbers. So notice on our X and Y axis, we have numbers on both. So there's numbers here and numbers here. And so when I look at this data, I also look at where it's from, and it looks like from Trinity University. So if I was going to have to guess, I'd say it's probably a small Christian liberal arts college based on the name. And the fact that we're looking at SAT scores kind of indicates that maybe it's East or West Coast, since in the Midwest we tend to use ACT. All right, so what do the blue dots represent, and where do they seem to cluster on the graph? So it looks like those are the students that were denied for admission. And so where do they tend to be? So if you look at the graph, they're kind of in the lower left corner, which kind of makes sense because they had probably, if they're over here, lower GPAs and lower SAT scores. All right, if you look at letter B, what do the green and purple dots represent? So they represent students who were accepted, and again, whether they attended or not, you know, doesn't matter, but they were accepted. And again, they tend to be up in the upper right corner, which makes sense because those are the students that have good GPAs and high test scores. You know, there are a few outliers or people that don't quite fit that trend. So, you know, that can happen where sometimes someone's accepted, but maybe not quite meeting the criteria. And C, notice that there are blue and orange dots representing students who were waitlisted or denied. All right, so why would that happen? So again, you know, you kind of look at this and you're like, well, some students look higher and they were denied than others. And so what might be is there might be something else at play. So meaning SAT and GPAs might not be the only thing that this college looks at. Some colleges might look at volunteering or how active you were, like if you're an athlete, either in high school or if you're going to be an athlete at that college, they might admit you with different requirements. It also could be that there's an essay, so maybe your SAT and GPA aren't as high as some other people, but you did an amazing essay, and so that is carrying more weight. So it kind of depends on, but overall, you can kind of see the trend here. All right, so why don't you pause and turn the page. All right, so I went ahead and turned the page here, and I'll try to see if I can center that a little bit. So a scatter plot has two kind of different data points, and again, they're numbers compared to numbers. So you're looking for a relationship between numbers, and you're looking for some type of correlation. So it looks like as horsepower goes up, miles per gallon, it looks like that's going down. So the faster, or I don't know if I should say faster, but the more horsepower I'm using, if you look, your miles per gallon are going down. You're getting worse gas mileage. And so you can kind of see a trend that this line is going down. So meaning the higher this is, the lower that is. All right, and we would say that's a negative correlation when one goes up and the other goes down. And so there's a relationship there. All right. Other things to notice is scatter plots have an XY axis, consistent units. So I don't know why they did the zigzag thing. Starting at 50 is only one more tick mark. So I probably would have started at 50, 100, 150. Okay, so independent and dependent do not make a big deal. Here's your, oops, I need a pen here. Here's your XY chart, and this is your input, and this is your output. So this is your independent variable and dependent, and it's really nice because it spells the word ID. ID. You are never going to just mess this up on a test. So independent is your X, that's your input. Dependent, oops, I don't know why that happened. Dependent is your output. And again, the idea is that your independent variable you have some control over. The dependent is the result of that. So for example, if I'm studying and I'm looking at a bunch of different students, so one studied 0 hours, 1 hour, maybe a couple people studied 2 hours, and maybe one person studied 4 hours. And then I look at their grade, you know, so maybe this person gets a 50% and this person gets a 60%. and this person gets an 80%, and maybe this person gets 90%, and maybe this person gets 95%. Okay, and so independent is they had control over how much they studied. The output is the result on the test, which, you know, once you study, you have to let go and just see what happens. If I made a scatter plot for this, again, what would I do? Well, I need consistent units, but your independent variable is always your x. Now, these numbers are not that big, so I would go by one. So 1 hour, 2 hours, 3 hours, 4 hours, 5 hours, and again, this is hours. And there's no need to use a zigzag thing because I have consistent unit. Now, grades, on the other hand, I don't have anyone that scored 10%, 20%, or whatever. So I could choose to maybe start at like, I don't know, 50%. And then I could go 60%, 70%, 80%, 90%, and 100%. Okay, and this would be like grade or something like that. So I have a label. Now again, this is totally legal to have this be worth 50 and then the rest worth 10. So what you have to do is do that little zigzag line to indicate that you're skipping all those values. Then you have consistent units, which is totally legal. Also need a title. So I might say hours studied, and then versus test score or something like that. Because I'm looking for a relationship between those. So at 0, let me actually change colors here. So the person who studied 0 hours, they got 50. 1 hour was 60. And they, again, are different people. I'm just looking at a correlation of a bunch of different people. So these people studied the same amount, these two people, but they got different scores, which of course happens. We all know that happens. And then 95. So if you look, there tends to be a positive correlation here, meaning that the more people study, the better their grade was, which isn't too surprising. All right, let's go back to the book. This next example in your book, there's a video online for that the author made. So I'm going to, or not the author, but somebody they hired. So I'm going to go ahead and let you look at that. All right, so if you scroll down to the bottom, let's see if I can move my little... Yeah, here we go. Okay, so if we look at this data, all right, and you're going to try graphing this. So just, again, pause, graph this on the next page, and see how it goes. Okay, now this top part I don't really care too much about here because, you know, they're just asking you like increments. Those are like going by tens or going by fives. Independent is X, and the so forth is the Y. So again, I'm just going to go back to this piece of paper I have over here, and I am just going to graph this. So again, you have some choices. Your graph might not look like my graph, which is totally okay. So we have our X and Y axis. Probably need a title, so this looks like salary versus what, experience maybe, okay. And so they wrote the chart horizontally, which I'm not a fan of. But again, if they do that, this is your X and this is your Y with all that data on page 82. But again, it still spells I, oh, sorry, didn't mean to do that. ID, independent, dependent. All right. So if I look at my years of experience, it goes up to 23. And I don't have a ton of space here, so I'm probably going to go by twos if I can fit that. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, hopefully 24. So again, maybe could do a little bit better job on even, but they're not bad. All right, and then salaries, it looks like the lowest is what? About 48,000. So I might go ahead and do a little skip thing here. Where's my pen at? And I might start at 40. And then 50, 60, 70, 80, 90. Do I have 100,000? Yeah, maybe. And then 50, 60. So again, see how these have consistent units? But I skipped a bunch of numbers there, so I need my little zigzag. And this would be dollar in thousands. Okay. Otherwise, you could put like, write them 90,000, 100,000, just put money, whatever. Okay. So now we would just plot these. So you would look and say, okay, the person that 0, they're at 48,000. Again, let me change colors. So they're right here. The person who worked 1 hour is at like, say, 67-ish. And 3 hours is what, 54-ish. And 4 hours is 58. And 5 hours is 62. And another person worked 5 hours, or what is this? Sorry, not hours, years. I wish. 5 years, and they make, what did they make? 64. So they make, what, a little bit more than the other person did. Okay, same years of experience. 11 years, so if I jump down there, I'm at, like, say, 74. 15 years is halfway between, and that's up at 81. And 16 is, what, 85. And 23 is 92. So halfway, we're up here at 92. All right, so again, what I'm looking for is a trend. It's not going to be perfect, but it looks like as, what do I need to label this? Years of experience. Yeah, so years of experience. But it looks like, I should probably spell it out. So as the years of experience goes up, so does the money. And so if they both go up, it's a positive correlation. Even if they both go down, it's a positive correlation because they match. So like, you know, the less I do something, something else goes down. So maybe the slower my speed driving, the less tickets I get. And so that's still a positive correlation because as one goes down, the other one goes down. And then a negative correlation is if one goes up, the other one goes down. So like the more I brush my teeth, the less cavities I have, that's a negative correlation. All right, go ahead and we are going to look at page, let me go back to the book